Dear participants and students and all the panelists, it's the recurring webinar of deep learning and its application, and myself is Chandranath Adak from JIS Institute of Advanced Studies and Research. This is this is a small promotional slide of our institute. We are offering several postgraduate academic programs, mostly MTech in computer science with specialization in data science and specialization in machine learning, MTech in sensor technology and IoT, MTech in bioinformatics, MSc in polymer science and technology with specialization in paint and coating, MSc in biotechnology and bioinformatics. So admissions are open. Here are some email ID. Admission at the JISIASR.org and info at JISIASR.org. Some phone numbers are here also available. So yesterday we covered mostly the neural network and introduction to the term deep, some hands-on application on optimizing a function. Today we will mostly cover the convolution neural network and we will build one hands-on application model on computer vision. And tomorrow we will mostly cover the recurrent neural network and one application, hands-on application on NLP or natural language processing. So again, the requirement to attend this webinar, I will pause for 10-20 seconds to give you time to grab pen and paper and computer with minimal configuration, some internet connection with Google account, because we will process all our programming tasks on cloud, and here we will use some Google Cloud Server. And the foremost thing, you all know that, is your kind attention. So again, one more thing, am I audible to everyone? Dr. Kaushik, am I audible? Hello, am I audible to everyone? Okay, thank you. So yesterday we covered this slide, so without wasting more time, we will just go on the term convolution. Just a minute, give me a second. Sorry for this. I'm writing here. So So yesterday we saw that we had some features, x1, x2, this thing. So and output is y. and neural network y was the function of x1 x2. It was our past yesterday's from the yesterday's lecture. So here, if we have and x1 x2, what we are calling these things, we are calling these features. So I'll come into this, what are the features here. So suppose if there are same multiple features like x1 x2, suppose x say 10. So last day, yesterday, in the input there was 2 nodes because we had only x1 and x2. If I have multiple input features, then I will have say 10 features, then I will have the 10 inputs node. So again, this will be connected to our Z. Last day it was Z was x1 W1 here the weight it was W2, so then W2 x2. So if I have 10 input feature, then obviously it will be W10 x10. Yesterday I covered the importance of bias, so here I have to give term. So suppose, so it may be 100 as well, up to 100 or anything. Suppose if I have a image, and today we'll cover the computer vision task. So that's why I am taking one image. Suppose I have an image of a say some cat. Okay. So here it is 10 pixel width and 10 pixel height. So I have here 10 pixels, 1, 2, 3, 4, dot, 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 say 10th pixel here also, 1, 2, 3, dot, 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 10th pixel. So every pixel is here x1. This one will be my x2. And this will be obviously x100. This will be x100. So this way, we can represent the input layer. This is the input layer. Input layer of a neural network. If I have multiple layers, I will come what will be the layer. If we have multiple layers, then it will be automatically, it will be the key. And what will be the output? Say, for example, say output I have, say this is a classification problem. So yesterday I also told classification, and our another member Rohan Mukherjee also mentioned the classification. So I believe you all know the classification. So classification is, suppose in this example, I want to classify cat versus dog. So our task is whether it is a cat picture or dog picture. So output will be 2 class. So if it is say 0, then it will be cat. If it is 1, then it will be dog. Simple classification. So there will be no problem to, as of now, there will be no problem to model this as a neural network, or sometimes we call it as, here multiple layers are there. I will come to this point. We call it also sometimes multi-layer perceptron. Here, and if the layers are so many, then we are calling is deep. So what is the requirement of the deep? I will come to this later on. So, but I want to introduce one term, that is convolution. Convolution, or more specifically, we will cover the convolutional neural network. Okay. So what is the problem of these types of architecture? There is a problem. Obviously, you all know that an image size is too many. Means one image contains so many pixels. Suppose here, say 1000 pixels. Okay, 1000 cross. Here it is also 1000. So how many pixels here will be the input layer node? It will be 1000 cross 1000. obviously it will be 10 to the power 6. So our architecture will be in the input layer, there will be this many nodes, this plus one, because another node is biased. So this many nodes, and output layer only 2 nodes. So you can understand that it is too much skewed. So the architecture is too many skewed, like it is 1,000 and here is also only the 2. So that's why we'll introduce the convolution neural network, and there are some more advantage. I am coming to those things as well. So at first we have to know some basic operation. Some basic operation is what is convolution on the perspective of the here image processing task. Convolution operation. So at first say I have suppose I have one matrix. For simplicity, I am taking one small matrix, say, and pixel value is nothing but from 0 to 255. In image processing tasks, the pixel value is from 0 to 255. So I am taking one small matrix. Say suppose there some value is 301274. So for this matrix, in every cell there is one numerical value from 0 to 250. So it will be one. Suppose I am taking one example, 1 5. Give me a second. I'm right. 9 1. Any arbitrary number. Just take an example, and we have to calculate. Just grab some pen and paper by yourself. 2 4 5. So it is on 6 cross 6 matrix. So now I am defining one kernel. This is suppose input matrix or some previous layer matrix. This is I am giving name kernel. There is some internal nitty-gritties here, like kernel, some feature map, those are things, but we teach this in our course in 1 hour webinar. It is quite impossible. So I am just giving one small example, like 1 0 minus 1, say 1. This 1 0 minus 1, this is the initial value. Yesterday I told you like W1, W2, initial value we took, say 0.2 here, 0.6, some values we took. Today we are taking some initial value, say 1 0 minus 1, 1 0 minus 1, like this one. So here, how many, and this W1 or WIs, these are called the learning parameters. This is the main thing. So here, how many learning parameters are there? This one is W1, W2, W3 up to W9. So we have 9 learning parameters for this example. Okay. So the convolution operation is very simple. So we have to multiply these two things in a tricky way. I am coming to this. What is the trick here? That was I am drawing this. So what we will do, we'll multiply this 1 with this 3. This 3 cross 3 we will multiply with this, multiply with these things. So multiply and add. So 3 into 1. So 3 into 1 plus 0 into 0, then 1 into minus 1, then plus 1 into minus 1, then again 1 into 3 plus 1, sorry, 1 into 1, then the middle column is obviously 0. So again 3 into 1, 1 into minus 1, 1 into 1, then 8 into minus 1. You just put some bracket here. Okay? So 2 into 1, obviously 2 into 1, then 0 into 7, and 2 into minus 1. Calculate what it will be. It will be 3 minus 1, 1. Minus 8 plus 2. So like 3 minus 8, it will be minus 5. So in this way you calculate, like the second one, this 3, I am sliding one portion. Okay, this. Now if we multiply these things, it will become, I have already calculated for saving some time, it will be minus 4. Now again, sorry. Again this 3 into this 3, it will become 0. At last, this 3 cross 3 into this 3 cross 3, just multiply and add, it will be 8. In the, it is horizontally, we have slided, remember this term, we have slided one position, like this 3 cross 3, then slided one position. In convolution neural network, this term is called as stride. Here stride equal to 1 because we have slided one position. Okay, this is called stride. It is horizontally we have strided, vertically also we will stride, like this thing into this. It will come, say minus 10. We will cover this, you can like fill up these things. So see here we had 6 cross 6, we have multiplied it with 3 cross 3, and we are getting a 4 cross 4 matrix. There is one formula that if we multiply these things, what would be the output? So the formula is n. You don't have to remember this formula, like for this time being, just I am saying how it is working, but in our course we say why it is working. So n minus f y s plus 1. So n is here 6 minus 3, 6 minus 3, and s means this stride. This one n, this one f, 6 minus 3 by s plus 1. See how much it will be? 3 plus 1, it will be 4. Okay. So one more thing here on another technical. One technical term is here. So suppose you don't want to reduce the size. Here it is 6 cross 6. You don't want to reduce the size. You want here also 6 cross 6. So what you will do? There is a concept called padding. Okay. In this padding, what you will do? You will just put this one box, like at 2 rows and 2 columns. Like here, I have put some say boundary, or I am giving some padding or protection to this. So here I am putting all over 0. Okay, 0. So it is called 0 padding. You can put 1 as well, like 1 padding. Based on the problem, you can put. So using these things, you can like come up with the exactly same number of the input. Here the formula will be little bit changed. Here will be n plus 2p, because here p equal to 1. So now check this formula. It was 6 plus 2 into p, 2 minus 3 by stride was s plus 1. What will be the output? S was 1, nothing to do. So it will be 6. So if I give 0 padding with width, padding with width equal to 1, p equal to 1. So it will give me the same number of input sides, same input sides. So it is called same. If we use padding, it is called same convolution. If we use no padding, the terminology is called valid convolution. In program, we will do these things. Okay. Same and valid padding. So another operation is there. Another operation. So this operation in this slide, we have performed the convolution operation. Okay. Another slide or another board, we will work on another operation. So another operation is very simple. It's pull or pulling. Suppose, and in the past layer, again I want to mention, there was the learning parameters was 9, because we have taken 3x3 kernel. So learning parameters was here W1 to W9. But in the pulling operation, we don't have any learning parameters. Pulling layer operation is like no learning parameters is required. What is simple things? Suppose you have 2x2 matrix. Suppose you have 10, 0, 20, say here 0, 4 value. So in the there is several types of pulling. Say for max pulling, we will take the maximum value among these 4 values. So output will be this. From these 4 values, we are getting one value, 20, the maximum. If it is average pulling, we will get 20 plus 10 divided by 4, how much? 7 point, here it will come, say, suppose something 7. Okay. Or you can take the bottom, like floor operation of these things, also. Like you can take 7 also. So what is this means? Like if I have again the same matrix, suppose I have 4, 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. In the same way, like if I take, say, in the same way, the pulling operation I am taking, say, 2x2 matrix max pulling operation. So here it will give me one value. So again if stride is 1, no, sorry, here one more thing. In the max pulling operation, we will take stride equal to 2. So these things, generally we take stride equal to 2. So here it will be these things, so another one value. Then this portion, say another one value. So here also, here we have already got these things, we are getting this. So from 6x6, obviously from the 6x6, what we are getting 3x half. So suppose we have say 100 cos 100 previous layer. In the previous layer we have 100 cos 100 input. Next layer after max pooling operation we are getting 50 cross 50 because we have taken stride equal to 2. Okay. So you can, in the same formula, you can put n plus 2p minus f by scribe. So here we are not taking any padding, no kernel. So n was 6, s equal to now 2. So 6 by 2 equal to bit. Okay. And one more operation is called flatten operation. So I have, suppose I have set 10, 2, 3, 4, 5, 6, 9, 8, 7. So after this, we can flatten this layer. The flatten means what? It is 3 cross 3. From 3 cross 3, I am getting one, say 9 cross 1 array. So 10 will be here, 10, 2, this thing 2, then 3 here. So like this one, this 9 will be here. So this operation is called flatten. So there are 3 major operations. I am just repeating again or writing it here. Convolution or conv, max pooling, or say here I am writing pool or average pool. One operation is flat. And sometimes in program we will write dense. Dense means full connection. Suppose in input input has 3 node. In the previous lab 3 node. Here say 2 node. So all node will be connected. Here these things will be connected. All things will be connected. So it is some sort of bipartite graph. So all things will be connected. It is called some dense connection. And remember some term, the previous day's term, activation function. So last day we used sigmoid activation function. Today we use this as well as some ReLU function. Sigmoid formula was I think you all remember 1 plus e to the power minus s. ReLU gives us, it is the function of max of 0, say x. Okay. So there are lots of things actually. It's quite hard to cover within half an hour theory, because next half an hour we'll perform some program that will be important for you because this webinar is mostly targeted for the students, the undergrad students. So during the program I will say more things. Okay. So here we will perform using Google Drive. Okay, we will upload all the things in Google Drive. So, and today we will cover the tasks. We will cover some classification tasks. Okay, we can cover some cat versus dog classification. So better thing is on the perspective of the medical things, you can if you have the database. So lung image of COVID patients or non-COVID patients, we can cover some glaucoma versus non-glaucoma as well, some eye image. So here for today's tasks, I have chosen the glaucoma data sets. Here at first in this data set we have to divide. I have already divided 10 versus test. It is 80% training data, 20% testing. Or here I will validate with this testing data. I will actually I will validate. Its name will be the validation set. So here I have some previous webinar. I think Professor Kaushik Bosar already like showed you some these types of image like optical cup image. So glaucoma, it is called glaucoma data set. Some images, eye images are there, retina cells are there. So he already covered. So we'll perform some program. Here it is some glaucoma patients, this image, and it is non-glaucoma thing. Okay. So what we have to do at first, we have to open our say Google Drive. We will not perform anything on machine. Okay, we'll perform everything on the cloud. So I am choosing my Google Drive. So here for saving some time, I already uploaded this dataset. Okay, So best way is upload this zip. Okay, upload this zip glaucoma detection dataset.zip. I have uploaded these things, and after that I have unzip this. So here in the unzip folder I have some train, those things. Train, under train I have non-glaucoma. Here also test glaucoma non-glaucoma. What I will do now, I will open the Google Colab. This editor, those attended yesterday's class or yesterday's webinar, you know that I worked on Google Colab. So here also new notebook. I have to change them and change my user actually. Though that my this drive is full already. So I'm changing this. So new notebook. So give this file name. I am giving name webinar day 2. Okay. So now what we have to do, we have to mount your Google Drive in this. See here now my Google Drive is not here. So you have to mount this. So how we will mount from? See here sample data is there, but nothing Google Drive. So from Google.colab import the drive. Okay. My screen is visible to all. Yeah. So here one command is that drive.mount. Here some content /G drive. Is a command, and I want to forcefully mount these things. Force remount. For the first time you don't have to force remount, but from the second time or not, sometimes it is required. So press shift enter. Here we will have one link because you need some access from your Google Drive. So click on this, sign in to your account, allow. Then you have to copy this code. Copy, then paste here, enter. Okay. So you don't store your data on this like your machine. So you just upload it, mount it at content at G drive. So see here G drive has come. My G drive has come. My drive, all my data is now here. Okay. So I have already unzipped these things. So here on command G drive sample. Yes. So ls it will show my like current things, this sample data, and that is drive sample data it will show. And now I have to change my drives. So I am just going to my drives. It is, you can copy this path, my drive, copy path cd, and so control V. You are now in the my drive. Okay. So there is a, after uploading these things, after uploading this zip file. Previously I have uploaded this zip file, and writing command I have unzipped these things here. Okay. The command is simple. Unzip. Oh, here is a some user. not unzip, then you have to just give this file name. That is, you just copy these things. You can copy this path as well, because we have already here. I am not just giving enter the copy path. So after using this command, you can unzip this thing. So I have already unzipped, so I am not using this command here. So now but when you upload the zip file, you have to unzip it. It's just a command. So after this, again, I want to go in this directory, this glaucoma detection dataset. So I have to copy path cd here. Okay. I am here now. Now we have to import the TensorFlow. So last day's command, import TensorFlow STF. Few more things we also import from TensorFlow. We'll import some packages. TensorFlow.keras import models. This model will help us to create some models. Models mean some convolution neural network model. From again TensorFlow dot layers. Okay. So we have successfully imported. Now we will create. It's a very few line of codes, because like the inner things, like thanks to this framework, we don't have to write the inner things. But for the research purpose, we have to write. We will make sure that our students write the inner things in, if someone is selecting our course. Okay, but for the webinar, it is quite interesting. Models dot, we will create the sequential model, because one after another, like here, like one layer, then second layer, then this sequential. Okay. So model dot, here is a sequential. Sequential, we will add different layers. Okay. So here, very simple, layers dot, for convolution conv, we will create convolution 2D. Conv, that convolution layer. Here I am giving 16 feature map. I have not discussed the feature map due to the shortage of time, but feature map is nothing but if we have those multiple. I have just put one kernel, one 3x3 kernel. So I had only discussed one layer. So I have the 9 parameters. So it may possible you have multiple, like stacked kernel. So here 9, 9, 9, 9. So overall learning parameters is say 4 into 9, 36. So convolution could be 16. Then the kernel size is 3x3. Then here I am using the activation function as value. Activation is value. Then the input shape of that image, input shape or previous layer shape. Input shape, I want to fix this as 224, 224 cross 224. And if we take RGB, it will be 3 channel RGB. And here I am using the padding equal to same that earlier I told, like same convolution or valid convolution. Here actually we have to write the padding. So one layer has been completed. Second layer is obviously the max pool layer. Layers dot max pool. I will use max pooling 2D. Max pooling 2D. 2 cross 2 max pool I will use. Now I will create multiple this layers. So I am copying these things. So layers again I will use convolution. Say I am increasing this 16 to 32. Activation same, input same. Now I am not padding here. You can use that time I have used the padding same. Now I can use using just for example. So layers max pooling is the same. Again another. Another say 30, 16, 32. Then I am doubling this thing. 64. So by default it is valid. Okay. So if you don't write anything, it will be the value. So now after like 3 convolution max pool, then convolution max pool, convolution max pool, then I am flattening. What I have told earlier, like layers dot flatten. Then I am just connecting all those nodes in the complete graph, dense connection that I already mentioned. So here I am giving node number is 512, and here activation is say value. Okay. Here I am putting another const, and here I am just giving output as one output. Yeah, our that convolution model is now ready. Okay, so you can check it as model dot summary. Yeah, here at first when shape is 224 max pooling option, it is getting half. Okay, 110, then it is getting half like this one. And you can draw this architecture as well. Like there is a command like f dot utils dot plot model. I have model. Then you can save this as well to file. Try to say my model name, say model plot dot say png mode. Then show save group. Then show say layer names group. sources. Yeah. So input I have not defined till now, so it is some question marks. But at first some convolution, then match pooling, then convolution match pooling, convolution match pooling, flatten, then translate. Yeah. So in this way you can draw the architecture as well. Now we have already put in folder the train and test, so we have to call those things. So my train, say G for glaucoma, train glaucoma directory is, here it is, yeah, this thing. Train glaucoma directory, train glaucoma directory is this thing. Copy. Train non-glaucoma ngdir. Again I am copying that part. Non-glaucoma, then test. So test glaucoma directory. Then test non-glaucoma. Test ngdir. So now there are some modes layer preprocessing things from tensor flow. But preprocessing. So we can augment some images. Input image. And we will import some optimizer as well. TensorFlow.keras import optimizer. And now we will compile. Oh, sorry. Spelling mistake. Now we'll compile our model. There is a command model.compile. So here loss I am taking binary cross and property. Optimizer I am taking optimizers. Learning, we have to define the learning rate. Learning rate I am taking 10 to the power minus 4. So it is written as 1e minus 4. And matrix I am taking as accuracy. Accuracy as a matrix. So now we have to generate the train data. Then data say generator chain. We will call this image generator. Our image size is a color image. I am just rescale it. Okay. So process it for. We can compute as a color image as well. Then dot data chain dot flow. Okay. This comes from the input. So here it will be this folder, this training folder. We have to copy this part. Our train data are here. Now target size is also we are defining as 224 fits 224, and batch size at a time how many data we are taking in one batch, this batch size, and even splitting 64 plus node binary. Yeah, here I just want to put the string. Sorry for that syntax. Spelling. Sorry. We have 365 image in this train data set. Similar way, this actually I am giving this name test, but actually this is the validation. Validation. Same one. So here also I have to copy these things. Yeah, I'm just copying these things. Sorry, like this way you have to define the validation. So, validation. Validation data gen. Same. Yeah, in the validation set I have 91 image, so it is like 80-20 ratio. Now we will train. So here again I am defining the batch size equal to 64. Say history dot fit generator, then train generator, steps per epoch. Yesterday I told you what is it. So I have 360. Ron, give me a few minutes, okay? Is it okay with you? Sorry, I can't hear you.
Hello, 5 to 10 minutes?
Yeah, 10 minutes is fine. Thank you. So, steps per epoch is 365 by say this thing batch size. Epochs. If you increase the epoch, then it will be the best. For shortage of time, I am giving epoch only 2. Okay, you can increase this as 100 as well, 100,000 anything for this time being, but there is some restrictions. Validation data equal to validation generator. Validation steps equal to, we had 91 test image of the validation image, so 91 divided by that batch size, and purpose is just styling how we will output the training things. So let's see. Steps. Some it's a little bit slow, so it's epoch 1 of 2. So after this, training, our model will be ready. So at the first stage, the training accuracy, yeah, this thing is 68%. Training loss, sorry, training loss is 0.68 and accuracy is 71. It's a little bit slow. Yeah. You can see when the epoch is increasing the accuracy is 2%, 52.7%. Let's write it next few lines on script. One epoch is so much. Set is test. Now epoch. So in the epoch one, the training loss is 0.5 and the validation loss is 0.4 and the training accuracy is 0.83 and the validation accuracy is 18. So if you increase the epoch, obviously it will, like, for this at this time being, the accuracy will increase. So raw, I'm just testing one image actually. Raw epoch. So raw dot size. Yeah, this step is done. So what we will do, we will test using some image. So in the online, you can search some image. Just give this link. Okay. So I have just in online, I have already searched and I am giving. Yeah, I am giving this link here. So I am getting this image as a test image, and then I am just fetching it to test actually testing this. So see, so prediction. So here I am using model dot predict, say some probability program, np dot expand dimension that raw image and axis equal to 0 axis. So So I have to import that. So I have some import issue. I have done this. So here you have to import few things. So I'm just copying this import thing. Okay. Let's see. Sorry. So here I am showing. Okay. Let's question. Okay, we will continue this thing from tomorrow. Like our next speaker is waiting for us. So if you have any question or sorry for this some runtime exceptions time. So we'll continue from this tomorrow and we'll cover RNN tomorrow. Okay. So if you have any question, just email me at chandra@jisr.org. Okay. Thank you and sorry for this runtime exception.